Session is related to planning experiments from 2019 session. The first one is the rate of a reaction between magnesium and dilute hydrochloric acid can be followed by measuring the volume of hydrogen gas produced. Plan an experiment to investigate the effect of decreasing a temperature on rate of this reaction. By measuring the volume of hydrogen gas produced, you are provided with a magnesium ribbon is there. We have a dilute hydrochloric acid. We have common lab apparatus. So we just want to find what is the effect of temperature on the rate of a reaction or decreasing the temperature, how the rate of the reaction is affected. So first, what we should do for a fair comparison, we should take, we'll take a known mass or measure the mass of a magnesium by using a balance. And we'll add example 10 cm cube of hydrochloric acid by using a measuring cylinder. Connect the gas syringe to collect the volume of a gas given off and measure. Then what we will do, we will repeat the experiment with a different temperature and find the rate of a reaction by measuring a change in volume divided by time interval. So the steps to carry out this experiment, example, we'll take 2 grams or measure the mass of magnesium by using balance. Whenever you mention any physical quantity, you should also mention the apparatus used to measure that physical quantity. So we'll measure the mass of magnesium by balance. Then we will take 10 cm cube of HCl hydrochloric acid and transfer to conical flask. Then we will add magnesium ribbon, measure the temperature, by thermometer. Then we'll add magnesium. Place the bung and connect gas syringe to measure the volume of hydrogen. Then record the time as well because we want to measure the rate of a reaction. So whenever we add magnesium here and start the timer and place a bung, connect the gas syringe and measure the volume of the hydrogen given or hydrogen gas in, say, example, 5 minutes. In 3 minutes. Then what we can do, we can repeat the experiment with low temperatures or different temperatures. Then to know how we can reach our conclusion, we can draw a graph between volume of gas or volume of hydrogen on y-axis and time on x-axis. Then compare the gradient the graph which shows steeper gradient is the fastest. So basically what we'll do, we'll take a magnesium, we'll measure by using a balance, and then we take 10 cm cube of hydrochloric acid How we take this 10 cm cube of hydrochloric acid? So we can mention by using a measuring cylinder, because if you want to transfer it quickly, if you want to transfer the solution quickly, we prefer the use of a measuring cylinder. If you want to measure the accurate volume, then we prefer to use either a pipette or a burette. So take 10 cm cube of hydrochloric acid using a measuring cylinder, transfer to conical flask, then measure the temperature by thermometer and add magnesium and start the timer. And then place a bung and connect this gas syringe and record how much gas is given off in 3 minutes. Then we can sketch a graph, change the temperature, sketch a graph, and compare the gradient or the slope. So the one which is steeper, it means that is a fast reaction. So this was from Feb March 19 paper. The last question, planning of experiment. Then from June session, a steel nail rusts in the presence of air and water. We have to plan investigation to show that coating steel nail with a paint helped to protect the nail from rusting. Show that coating the steel nail with a zinc also protect the nail from rusting, and determine which coating is more effective at protecting the steel from rusting. So what we have uncoated steel nails are there, steel nails coated with paint, steel nail coated with zinc, and we have a common lab apparatus. So what we should do, first thing, we'll measure. So what we should do, first thing, we will take like equal mass of the nail in 3 different test tubes. The one which is not coated, the one which is coated with zinc, another one is coated with paint. And we will add equal amount of water, and we'll leave it for like, because rusting is a slow process, so we should leave it for like about 2 weeks or even 3 weeks we can leave them. And then we will filter and rebate the gas, the one which shows the smallest change in the mass or negligible change in the mass, or is having a small quantity of a rust on it, that is the most suitable coating. So we'll take equal number of steel nails in 3 different test tubes. So that is the first point. We'll take equal number of steel nails which are there in a 3 different test tubes. Then after that, what we will do? We will So after that, what we will do, we will add equal amount of water in 3 test tubes. And when we take equal number of steel nails in 3 different test tubes, one test tube uncoated, the first test tube will have uncoated, the second test tube zinc coated, and the third test tube painted. Then we'll add equal amount of water in 3 different test tubes. After that, we will leave the apparatus for 2 weeks because rusting is a slow process. After leaving it for 2 weeks, we will filter and dry. And what we want, because we want the rust layer to be removed from it if any rust is there, so we can also scratch by using a sandpaper. So filter and dry and reweight again. Here you can mention the first part, take equal number or equal weight. Then we will reweigh again. Or we'll reweigh and compare the mass. The test tube, which shows the smallest change in the mass, is more effective coating. So that's how we work out like which coating is more effective. So for a fair comparison, we took one with the uncoated, one coated with zinc, another one coated with a paint. We take equal volume, keep the equal volume of water and keep all the conditions same so that we can identify which one rust faster or which one rust slower. Then another experiment is there from October-November session, that iodine dissolved in two solvents. We have ethanol and hexane. We have to plan an experiment to find out which solvent iodine is the most soluble. So what we will do in this experiment, iodine is a black or a purple crystal. So we have ethanol. We'll take equal volume of ethanol and hexane in two different test tubes. Then we'll add a known mass. Like example, we add 5 grams or 15 grams of iodine in both of them. We add 15 grams of iodine in ethanol and we add 15 grams of iodine in hexane. Not all will dissolve. Some of the iodine here will be insoluble. Some iodine here also will be insoluble. Then what we will do, we will filter, dry and compare the weight again. The one which is having the smallest amount of undissolved iodine, it means the iodine dissolved most in that solvent. And we'll make sure that the temperature is same for both of them, amount of the liquid also same, and the size of the crystals also, which we are using for iodine, remains the same as well. So we'll take equal volume of ethanol and hexane. We will add, like example, 15 grams, any mass you can mention, 10 grams of iodine in both test tube. We will stir and then we'll filter and reweigh, dry and reweigh or weight again. And then we'll compare the mass of undissolved, the one which having a smaller quantity of undissolved iodine, that solvent dissolve the most iodine. So we will take 10 cm cube of ethanol and hexane in two different test tubes. By help of Beijing cylinder. That is one thing. So after that, what we will do, we will add, for example, or measure the mass of iodine. By balance, and we will add equal amount of iodine in two different test tubes, in ethanol and hexane. Then after that, we will filter, we will stir, then we will filter to remove undissolved iodine. After that, we will dry by using a tissue paper or desiccator can be used. Then we will reweigh again, reweigh, and we'll compare the mass of undissolved iodine. The test tube which shows the smallest amount of iodine or undissolved iodine is most, which shows that iodine is most soluble. The test tube which shows the smallest amount of undissolved iodine shows having more solubility so that's how we can compare these solubilities of different solvents.